Well, hello there, and welcome back to Advent of Code day 22. So, yeah, we did get the answers for day 22, part 1 and part 2. It wasn't that difficult of a puzzle, but our solution is, well, let's say it's not something that I'm very pleased about. Very messy code and a bunch of things that I think could be refactored into some better shape. So that's what we are here for in this video. We can probably get rid of some of these, but it's really nice that we got now this waterfall flowing. Okay, so let's review a little bit of what we have and what we could do. I can probably also take notes on the README of what to do. Oh, I haven't taken notes of since day 19. Well, let's leave that for later, but let's make some annotations of some notes about what would be nice to do. So lots of things. One that really comes to my mind immediately is this use of like nested tuples, because we are modeling each brick to be well, it's a tuple of 2 points, and each point is a tuple of 3 numbers, which is not bad, but all of these things being unnamed causes this kind of situation where we are accessing like new brick.0.2, which is quite ugly to read. So maybe that's something that we can get rid of, because I think we could model, well, either we can make the brick itself be a struct with start and end fields and make it more readable, but also we have that, but we also have a function that is called like brick points. That is also something that I would like to change. That is returning like a dynamically dispatched iterator, which it's like not great. I think this is more complicated than needed. This takes a brick and gives you back like, well, an iterator that iterates through all the points of the brick. But instead of doing this, I think we can just make the brick itself be its points, and we can make this sort of logic while we are parsing the bricks, and that's it. Like we get rid of this nastiness and the nastiness of accessing the brick like this. So let's take note of that. Remove dynamic dispatch. Remove dynamic dispatch and make brick be just a bag of points. Yeah, so that would be nice. Then we have this logic of falling the bricks down, and we have like 3 pieces of mutable state here, like the grid, where we are taking note of where what position is occupied by which brick. I think we need that. And we also then have 2 different, these are basically indices of which, how do you say, like which bricks support what. Like the support is like, okay, given this brick, what is this brick supporting? What are the other bricks that this thing supports? And supported by is like the inverse of that. Given a brick is like which bricks support this given brick. And I think we need both things because, well, in the previous session when we implemented this, we noticed that if we didn't have the inverse, the supported by index, we have to make a lot of like linear searches on this, and that got pretty slow. And when adding this, it got super fast. So that's also maybe something I don't know, I would like to reconsider this, but I'm not sure what to do. If there is some obvious data structure that could allow me to do like the bi-directional mapping. It's like a many-to-many relationship. If you're talking like in database relationship, relational databases, this would be like a many-to-many relationship, and you could have like two indices for that. But that's exactly like what we're doing here. The two indices are like the two vectors. But I guess we could also maybe try to use hash sets for this instead of vecs, so that it's easier. We don't need to ask if things are contained. We just append things, and yeah, we will trade some linear searches for O1 operations. So let's take note of that. Maybe change supported by to use hash sets. Okay, then we have this falling logic, which I think we can probably review and try to tidy up. I won't think about that now, but tidy up falling logic. So brick falling logic. So that is that. Oh, and then we have the answers to both questions, to both parts. And I think this is one of those cases where like part 2 is like a more general problem than part 1, and we can retroactively implement part 1 in terms of part 2, because on part 2 we are asked to count how many bricks will fall if we disintegrate each of the bricks we have. And on part 1, we are asked which bricks are safe to disintegrate, so which bricks basically won't cause any bricks to fall. So we could easily implement part 1 in terms of part 2. That is basically is asking the same question as in part 2, like how many bricks will fall if I disintegrate this, and if it is 0, then it's safe to disintegrate, and we just count those. So implement part 1 in terms of part 2, or something like that. This is probably going to also be removed, because I think we can do when tidying this thing up. I think we will get rid of this also. Fall 1, I guess move down could be a better name for this, and then we have this recursive function, which I really would like to make it not recursive, because this is like a example of recursion used for something kind of nasty, because instead of like thinking of this as a function without side effects that returns something and is kind of like delegates to itself, it actually is mutating this. This is basically the output of this function. So I want to make this function make non-recursive. And I think it's a pretty simple recursion what we are doing here, so we should be able to write this in a loop and have this thing be just a mutable variable inside the function itself, and instead of having to pass something from the outside and modifying this inside and then passing it around, like this is really ugly. So yeah, I think that's basically everything that I want to change. The parsing is okay. These assertions could be removed probably, or even ignored. I don't know what would happen if we ignore them, but they are just to make sure that our input doesn't make us crash. And yeah, that would be it. Let's also take a note of, I have a failing check. Maybe that was No, that was probably because of some other modification. I also want to time out how much this thing is taking to have an idea if this needs some optimization. No, it's 47 milliseconds. It's fine. But let's take note of this. Initial runtime is like, wow, 50 milliseconds, let's say. If we go over this, we have done something wrong. All right, so where do we start from? I'm tempted to do this remove of dynamic dispatch, but I think this will be a side effect of doing this. Just make the brick just be a vector of point. So let's start from there. Instead of being a starting and end point, let's make it a vec of point. And probably also this type alias is probably going to be removed. Yeah, let's actually assume that we are going to remove that. Let's go back to let's go back to this, and let's put here when we parse. Just say, okay, we're going to return a vector of points, and inside of this, we're going to basically do this kind of logic. What's let's say, well, we can just say let's remove all the new boxes. Also remove this. I think I removed something that I didn't want to. But if x1 is different than x2, let's go from x1 to x2. Map like this. This is basically the same logic as the iteration to generate the breakpoints that we were doing before, but we're just going to collect this into, oh, this is result. Okay, then yeah, because this has the parsing can fail. So let's just say let points be this, then have an else if, and then an else. And then return an OK of points. Okay. So you cannot be built from an iterator over elements of what? What is points? What's your type? That's probably not inferring the correct thing. Oh, there's a return here. Let's also do a collect here, and let's also do a collect here. How about that? Oh, okay, now it's not complaining anymore. I don't think I can move the collect out of this. Let's try it, but I'm pretty sure. Can I? Can I like do collect here? No, right? Because yeah, they are different closures, as you can see here. And even though we are doing sort of a very similar thing with a range and a mapping of a range, the types of closures are always different, and we will need dynamic dispatch for this to work, I think. Unless we make this closure. Let's maybe do this. I mean, but there's no need for that. The moves, I think, are not necessary. Yeah. Okay. Great. So the parsing of the bricks, let's assume that it's fine. Then the sort by key, this will take a brick and, well, return the Z coordinate of that brick. We could, this is also not the best, but there is like a, I guess one invariant here would be that these vectors cannot be empty, which I think, since we are going like from Z1 up to and including, like all of these ranges are inclusive, that there is going to be at least one element, always. So that's good. Actually, I think we can get rid of these assertions. We can then check. Let's actually write down this assumption here. What happens? Inclusive, let's say. What happens if we do whatever, like 7, like if the start is bigger than the end, but we do it inclusively. If we do then a collect vec, I'm expecting this to print 5, to not be empty, but we will check. We'll run that when this is runnable, which right now it's not. Okay, so now we need to work. The only thing that needs to change, I guess, is this brick falling logic, because after this we don't use the breakpoints again. That's also something nice. Then we after that we only use these supports and supported by vectors. So that also tells me that we can maybe extract this into a function that returns these two things, and have the grid just be something like inside of that function. But anyway, we will go over each brick, have the brick ID, and this idea of having like new brick, this is, I think, not necessary. The condition of the brick falling up to 0 is the same as whether the brick starts at 1, basically. If the brick, like this is not empty, so we know this, and if the set position of the first point is 1, I guess we can even ask, now let's ask if it is 1, then that's it, that's the resting position of this brick. And we can just simply then ask, say, for point in brick iterator. That's it, the brick is already an iterable thing. We put these points there. That's awesome. Then here, same thing, although we are iterating over what was the new brick. So let's say brick iter. This is not a new point, this is our existing point, but we can extract it like this. And when checking the grid, we can ask, hey, is there some other brick in x, y, z minus 1? And that's how we try to lower this brick. And you don't like this because we can probably dereference here. Okay. If we don't dereference there and we don't do this, what's your point? Yeah, that's a problem. Okay, let's do this. This is a bit messy, but let's ignore it. For now, we are just doing the refactor of bricks into vectors. And this breakpoints also should change to brick point. So this means that the brick is colliding. So we leave the brick where it is. Great. And then if it didn't collide and it didn't reach the bottom, then we should move the brick down. So this is the part where we move it down. And we don't have a new brick to do this, but we can just do for, well, x, y, ignore x, ignore y, z in brick iter mute, which is going to do z minus equals 1. So we lower the brick. And I think that should be it. This is complaining because range is empty, so it will yield no values. Okay, thank you, Clippy or whoever you are. Okay, it's a nice thing to tell me about, but oh, no. What I want, I should say foo here, and let foo be 7. Aha, fooled you. Use of disallowed placeholder name foo. Come on, Clippy, you're too pedantic. What if we run now with the actual input? So let's run with sample. I don't know. Sample. Okay, yeah, this thing was empty. So that's interesting. If the input is messing up, like, yeah, the input could mess us up. So I guess we will have to put some sort of condition there. But it seems like the refactor was successful, like we are having the same answers for the sample. And there are some unused things, like, yeah, fall1 is not used. The brick type is not used. This dynamic dispatch is not used. That's awesome. And do we have still the same? So let's run the checks. Check all. Yep. And if we time this, we are still in the 40 milliseconds. It even seems like it's faster than before. So that's awesome. Or maybe that's just noise. But yeah, this was nice. The only thing that I don't like about what we did was the removal of these assertions, because it seems like we need this to be the case. Let's copy these things and bring them back. But instead of being assertions, yeah, we want this to be the case. I like writing this like this. Like, to change this to return a result is a bit annoying. You know what? Let's leave the assertions there, but make it another point. Remove asserts. So okay, right now this passes all the checks. I think it's already a nice improvement over what we were doing before. I think probably also is less code. Well, not so much, but it is something. Like, overall, we removed the dynamic dispatch, and it makes more sense, I think, to have the bricks just be a collection of points. They are like easier to work with, and yeah. So this is done, and this is done, and this can be committed. Say make our day 22, make bricks a be a vector of points instead of a start and tuple. This gets rid of the iterator dynamically dispatched iterator. Yeah, I think this is the best thing about this change. Okay. What else? This change of supports and supported by to use hash sets and tidy up the brick falling logic, I think they are pretty related. Yeah, they are pretty related, I think. Let's try the first thing. Can we write this as hash set new? I'm not sure if the vector macro allows this, but okay, yeah, we're doing push here. We are going to do insert instead because that's the method on hashes, but we don't need to ask if it's contained. So we just put things there, which is nice. And these should now receive, instead of vectors, these are going to be hash sets. And everything else I think should be the same. Yeah, we're iterating over this, and for supported by, we are iterating. Oh, this is also something that with hash sets can be simplified, I think, because we are iterating and asking if any. Yeah, this falling bricks is already hash set. This basically is asking if there is any intersection, I think. But okay, like with this change, do things still run the same? It seems so. And if we time it, well, we did increase the runtime there a little bit. Not so much, but by quite a bit, I guess. It does make this some of the code a bit simpler, but some other is not so much. So is it true that this is kind of the intersection of two things? Falling bricks and supported by of this. If any is not falling, yeah, I think we written like this, it kind of makes sense. I'm not sure if I like this change. Let's go back to the vectors for a tiny bit, because I think we can probably think about the simplification of this code besides this. So let's try to do this, the tidying up of this. First of all, the thing that we are doing when we reach z equals 1 and when we collide is basically the same thing. So I'm wondering, if we are already at 1 and we try to lower to 0, nothing will change because you're not going to collide with anything. It's just that it's kind of unnecessary to do that, but I think that brick falling logic is not what's taking most time. So if we put this condition here, like say, okay, if it collides or it's at set 1, we do this. Ooh, interesting. Now we can type inference problem because of changing this. What? That's weird. What's your problem. Why can't you do this? Why? Because of this change. Cannot infer the type, but you were able to do it before, and we were not using the supports. That's weird. If I put a type in here, hash map of point to view size. Like if we have the type for for this, then this is no longer complaining, but we were inserting references to points. That's interesting. It's kind of interesting. I didn't realize that. I think that's actually kind of, maybe it was a change, because before we were using iterators over points. Yeah, okay, let's insert it like this, or dereference it here. So yeah, now it's the correct type. And if, like, no, this brings back this problem. Okay, it's kind of weird, you know. And this turbofish, I have to say I'm not a fan of the turbofish thing in Rust, but yeah, let's make the compiler happy. I just wanted to see if this condition still makes everything pass. I think it should. I don't know if it's slower. Maybe a tiny bit. Not sure. It's probably noise also. But yeah, the code is a bit. We are not doing like this thing in two different places, which is fine. My cats are sleeping on the desktop, on the desk, sorry. So about tidying up this code, there is this thing of having this mutable variable collides here and doing this such an imperative way. I think here what you're doing is we're going over all the brick points and asking if there is another brick ID on the grid. Yeah, and if there is, that means that that other brick ID is going to support this the current brick. Yeah, I think we can change this. We can change this to like a much more iterator-based solution instead of being so imperative here. I think it might make it more readable. But this little change that we have of moving the conditions here, I think I'd also add it. Okay, so what we are doing here, basically, let's say what I want to do is something like, gonna be iterating over this, right? Gonna say something like, let supporting bricks be, we're going to iterate, we're going to map, right, some things. This goes up to here, and then we're going to, I think, just say collect vector. Just collect vector. and I just want to extract this other brick ID. And that's it. I think just doing, yeah, this is what I want to do. Just get whatever is on this. We're going to need to mutate those things afterwards, but let's put it here and comment it. And here, let's just do grid gets of what is below this. Yeah. And this will be supporting bricks, I think. Right? Yeah. Well, no, because this is a vector of option of usize. Great. Let's actually do a filter map of this. This is now vector of usize references. Great. Can we? This is an option. Well, it's fine, right? How can I just do it simply? Maybe map this option. I just want to dereference it. This is going to be an ID, just dereference this ID. Not super pretty, but yeah, now it's a vector of usize. And this could have repeated numbers supporting bricks, because like if a brick is many tiles, many points long, and is supported by another brick that's in the same direction, it can be supported by many points of that other brick, and we don't want to double count, I think. So maybe we could collect into a hash map. Is there like a unique thing? Look at that, unique from iter tools. What does unique do? Nice. I think this is needed, but let's comment. I'm not sure, but I think it's going to be needed. But with that, this is the supporting bricks, so we can just then write supported by of this brick ID should be this supporting bricks, right? It should be just that. And here we will have moved out of that. So I also want to do something like for each supporting brick in supporting bricks iterator. Well, I want to do basically this condition here. If and this can probably be dereferenced here. I think, okay. I think with that we should be populating the supported by and the supports indices, and then the collides is just a matter of asking if supported bricks, well, we can say like let collides is basically if supported bricks is not empty. So it's empty, it's not empty, then it collides. and you cannot use this because it has been moved. Yeah, let's compute it before. I think that should be fine. And you are complaining because you are using an explicit closure for copying elements. Consider, yeah, we can use copied for this, sure. But I mean, is there a copied? Oh, look at that! There is a copied on option. I didn't know about that. That's cool. That's cool. You learn something new every day. Thanks, Clippy. Does this thing run? Well, it does run. Does it pass all the checks? It seems so. Great. So we don't need to ask unique. Why is that? This is the supported by, which we are using to check if any. Yeah, I guess it doesn't need to be that, which is fine. It's fine. And then what we are doing here is, yeah, for each of supporting brick, we are saying, okay, this supporting brick supports this brick. Yes, 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 yes. Okay. Okay, okay. Yeah, I think this logic now is a tiny bit, at least, less imperative. I want to get rid of this unique, and I also want to get rid of this contains checks. So I'm going to, like, okay, let's add these changes. But I'm also going to try again with that little change of being hash sets. Something like this. So this should be now insert by and by. And, well, you are incorrect type, but we can just collect into a hash set. You need a type annotation, sure. You can have one. And here, this function should receive a hash set and a hash set of users. This will make things a bit slower again, I think, but I mean, I do prefer the code of not having to ask around so much. So if we do this, yeah, but we're still on the 50 milliseconds, so it's fine. It's 65, yeah, it's fine. Is there a better way of writing this? So for each supporting brick, we are changing supporting brick, we are inserting that brick ID. So I'm not sure if there's a better way of doing this. I think I'm fine with this. Then it collides if the supporting bricks is not empty. Yeah. Yeah, perfect. And if it collides or if it is at 0, the set value is, well, 1, then we stop. Great. Otherwise we go down. Yeah, that seems a better logic for this falling of bricks. Does it make sense to move this into like extract this into a little function? I'm not sure. Let's maybe, what are we going to need? We can have the bricks. Let's maybe try it into a function. Well, the extraction, like I'm surprised how good the extraction, like that refactor is for Rust Analyzer. Like it's, yeah, it realized that the only thing that needed to be returned here were this supports and supported by. Vectors, and it's just doing that. That's great. So this will be, what we are doing is like, okay, make the bricks fall. So we also are passing the bricks. Oh, it's taking that, taking it by value, by move value, which is interesting. This should be point though. For bricks, I don't know. Do I like this? Like, this is also consuming the bricks, which is like, it's fine. Like, it's not bad, because we are not using the bricks anymore after this. So it is quite useful. I am actually kind of liking this. We can even get rid of this, I think. The type annotation. Like, look at this. I think we can, yeah, maybe get rid of this. Get rid of the mutable thing. And do the sorting inside of here, because I think like the sorting of the bricks is kind of, you know, something that only matters to this guy. So, supports and supported by. Yeah, that's not so bad. The signature of this function is a little bit busy, but I mean, it's also not so bad. This thing only works with indices, and the indices are of the sorted bricks. But I mean, fine, I guess. Yeah. After this refactor, do you still care about this? Do you still? Yes, you still do. Okay. Okay, this should still run, right? Yeah. Yes, it does. Yeah, we have the parsing of the bricks, then we fold them down and we just work with these two things, which I think is fine. So let's actually add this change. I liked it, actually. So we did tidy up the brick falling logic, and we actually moved it to another function. And we did this thing of changing supports and supported by to use hash sets, which is great. Let's commit this. So tidy up and extract brick falling logic. All right, what's next? Implement part 1 in terms of part 2, make this thing non-recursive, remove the assertions. Let's do this first. Let's go in order. So yeah, we're also not using the bricks because we are for the bricks. We are sort of not using the bricks because we are just using the brick, the supports, like these vectors that we are returned from there, which is like, yeah, it's fine, right? I think so. But yeah, let's do something. Let's do the thing of implementing part 1 and part 2 in terms of the same freaking thing. These supports, can we actually ask for the indices of this? Like instead of saying iterate, because here we are enumerating over this, but we are not even using the values. It's just, we're just going over the indices of this thing, which is a bit sus, to be honest. This surely does exist, right? Rust iterates over vec indices. Yeah, it's not enumerate what I want. I know about that, but if I don't care about the value itself, it's not a very common thing, I guess. But I'm surprised if it doesn't exist, to be honest. But anyway, it's basically this thing that we want to do, like the count of for each how many they will fall if the brick is disintegrated. So this would be, let's say, fall counts could be, yeah, by brick or something like that, but yeah, fall counts. It's gonna be this. We're gonna map into this thing, and we're going to simply collect as in a vector. Yes, that's what I want. And then, well, I got rid of this, but you can say that this is fall counts iter sum, and count is a vector of this. So yeah, can you just be something like that? Sure. And this save this integration count can be also implemented in terms of that is going to be for counts, well, iter and filter. We're gonna get the count, and if the count is 0, basically, that's what we care about. We want to count those cases. And this count is probably a reference, so let's dereference here. And are you a double reference? Yes, you are, because the filter does that. Yeah, let's double dereference here, sure. And you can be removed. And how about that? Do the checks still pass? Yep, they do. And runtime should still be basically the same. But now we don't have like specific logic for part 1. Well, it is just implemented in terms of part, like the same logic as part 2. So that's also nice. Save disintegration count, total fall sum. Yeah. Yeah, okay. Right, that's also a nice little refactor, which should get rid of some lines. Yeah, we are almost at 100 lines. Let's commit this, implement parts. This is day 22. Print parts 1 and 2 in terms of the same logic. Something like that. All right, and finally, or almost finally, make this thing non-recursive. That's something that I want to do. So count false if disintegrated. Yes, we pass a brick ID. This, I think, should be a function that just returns the count. So yeah, falling bricks. Let's just try to pass what makes sense and hope for the best. We're going to need, however, to do this. So let's actually yank this from here. Go to the definition of this. And we're going to basically have this inside the falling bricks. And I think we are going to start just like this. And we're going to return just this. So this is not going to take this recursively as a mutable thing, which is ugly. It's just going to return a usize. Okay. So now the falling bricks are going to be collected like this. Does this make sense? What we were doing recursively before, though, it's like we are we have to loop over these things. Have to loop over this. How do we go about that? We then call this recursively. So this is kind of, we're pushing all of this, we're calling it like that. So is this a stack or is it a queue? Like, is it FIFO or LIFO? Let's think a little bit. We are starting from some brick, it doesn't matter. We're trying to, well, we consider it falling. Then we push whatever is unsupported by it into the falling bricks. And then we were calling that thing recursively for each of those. So I think it should be a queue, a FIFO. So unsupported. They are already falling. Yeah. Falling bricks. Okay, let's have another. Let me simply call it Q. This is gonna be vec. We also need to start from this, right? From iter This is a little bit of repetition that is a bit ugly. Falling bricks and queue, they look kind of similar. But then we're gonna have the usual queue consuming logic, while let's some brick ID be the queue pop front. I'm not actually sure if this is FIFO or if it even matters, but let's assume it is. Like in my head it made sense that it was. So we're going to pop from the front, and then here instead of the recursive call we should push into this thing. So unsupport now queue, just push back the unsupported brick ID to be processed. The support and supported by don't change, and the falling bricks do change, but it's just a local variable. And you need a type annotation? Thinking falling bricks and explicit type. Why do you need a type annotation? You are a hash set of use size and s, but s is like the state thing for the hash. Why is this thing needed? What's going on here? Falling bricks. You are starting from a brick ID, and then you're just being extended here. If I say like hash set of whatever, would you be happy? Like what? How is that even possible? What's going on there? I don't know. But okay, sure. I mean, yeah, sure. I don't understand what happened there, but do the checks still pass? Yes, they do, and running this still yields basically the same time as before. And yeah, we changed this function to be non-recursive with a good old for loop. And I do wonder, we are going to add these changes. I do wonder if this needed to be a vec deck, if we needed to like pop from the front. If we do a pop back, does this still run? Well, yeah, it does. Why does it run? Well, because things are already, falling. We are preemptively putting this here, so it doesn't matter what order we are doing this, so that's fine. So then we can just use then a simple vector for this. Instead of pop and push back, we can just say pop and push, and the queue or deck is no longer being used. This should still run and pass all the checks. Yeah, great. So it's no longer a queue though, so falling bricks, these are if disintegrated. We are shadowing also this. Oh no, what did I do? We're also shadowing here this brick ID, which might not be the best idea. Unsupported bricks, support, but that's all right. Yeah, but this is definitely not a queue. So how do we call this? To fall. Yeah, to fall. Great. Yeah, we're collecting this, and this makes sense. This also, I think, needs a comment of why the -1. So subtracts 1 because we don't want to count the initial brick itself. Okay. So this is not bad. It's better than the recursive thing. Unsupported bricks. I don't even know. I have this mixture of like collect of things, collect tuple, collect vec. Well, only those two, but since I'm already using like these things, I can do a collect vec here and get rid of some type annotations at least. But I'm really like surprised about this explicit type annotation. Like, why wouldn't from iter do give me back a hash set? Like, what does this add? I don't know. But okay. So yeah, we start from there. Let's put this first, because this thing, well, I don't know what makes more sense. This is being used for the return value, so I guess this is the most important thing, and this is like how we are processing stuff. So we can even put it kind of like that. Yeah, nitpicking the code. And by the way, this thing inside, we are getting the support for what this brick ID support. We are copying this iterator. What? Why are we doing the copy there? Why are we doing this? Oh, the filter is, yeah, but this shouldn't be needed, right? We can kind of do that. No, yeah, we're doing the copy because we want to collect into vector of u size, sure. Unsupported breaks. Oh, and since here we are not doing the yeah, this is interesting. Falling bricks and to fall. This is no longer a recursive function, so basically we can do kind of the same thing. This is also like the same as above. Can extend with unsupported bricks in there. I think this does need the iterator because otherwise it's going to be moved. Yeah. But other than that, this should work the same. Yes, and this check of, okay, give me what this thing supports, supported brick ID, and then give me what this is supported by. If there is any where falling bricks. I think asking this any here isn't it the same as asking if all of these, like what they are supported by, if they are all falling? If they are all falling, then this is not supported. I think it's the same. Yeah, okay, yeah, and I think it gets rid of like 2 negations, and I think it's easier to read. Okay, so that's pretty nice. Always nice to get rid of some very nasty recursion with, I mean, I love recursion, but recursion mixed with like mutable parameters is like pretty ugly to see. So let's commit this day 22. Make, how is the name of this function? Count files. Count files is if disintegrated. So it's basically, yeah, it's not a bad name, but the description called it something else, like a chain reaction. I think something like that would make a bit more sense. Like count brick fall chain something. But it's fine. The name the name is all right. Convert nasty recursive function into imperative one, into imperative logic. Okay. And I think that's mostly what I wanted to do. There is the removal of asserts, and I left this for the last because I was thinking, like, I do like these asserts as they are written. We could also write them as chained, like x1 less than or equal to x2 and x, like, and this and this. I don't want to transform this into an if condition and then return an error, but that's basically what we have to do because as far as I know, like, Rust standard library doesn't have like an assert that gives you back an error, but anyhow does. And I was wondering if maybe this is a good opportunity to try out anyhow for error handling instead of our own bespoke result type. So I'm just going to try that out. I have read about anyhow not too long ago. Like, we have this, which is just a type alias for result of a box dynamic error, which is not which is a pretty common thing in Rust. I think a pretty common pattern, just box into like a dynamic trait object But I would like to have those niceties about from anyhow, and also anyhow has some other goodies, like it comes with, oh my god, my cat almost munched the cable from for my microphone, damn it. It also comes with support for back traces by default, which I was surprised to learn that Rust default result types don't, which I think is being corrected, but it's not stable yet, so, or it's not on by default. So I was surprised by that, but supposedly anyhow does have it. So let's do a cargo add anyhow. And you can see that, yeah, I had already tried this at some point, but didn't really go with it. I was just trying things out to see how it worked. But now we should have anyhow, and we should be able to say, hey, this is an anyhow results. Isn't this correct? And this thing here. So what's the problem here? The trait stir is not satisfied. What a nice error message. What's going on? Is it because of this okay, or like we are converting this static string to, I guess, before we were converting that into dynamic error? Huh. What does it say? Require string slice to implement instead error. Oh, required for. This is using the dynamically boxed error. This is a lot to learn about. Take advantage of that. Okay, there's an implementation for from string, so that's why it used to work. I think, yeah, anyhow has this like context functions, which I think is probably what I want to do here. Like this is giving me back an option. Can I just add a, yeah, with context and context? Oh, okay, this made the error go away. So context from anyhow is kind of like what we were doing before. That's fine. Does anyhow have like a prelude or something? No. Well, let's leave it like that. So this should run, right? One nice thing about, well, it's probably compiling anyhow there. Oh, I killed it, but I didn't mean to. This is a nice thing about this pattern of having like different, like the structure of my project here that uses different like binaries for each day, makes each binary be independent from each other. So this is the first daily solution that uses anyhow, but I don't have to change everything else all at once to try out this thing. So that's also That's something really nice, I think. Okay, so that's nice. And I think anyhow has something like ensure. Look at that. Ensure. Does this have? Well, doesn't have documentation there, but in Rust anyhow ensure. Let's close out things. Yes, I have already been reading about this, but is this what I want? It's not. Yeah. Okay, it's equivalent to this. It's an error of anyhow of some things. Great. Great, that's awesome. So yeah, then we can say, I guess we can make our AOC like this be a type alias for anyhow results, and it should be fine. But yeah, we can ensure this and this and this for, well, y and then for z. That should be pretty good. And let's do a cargo run of this with a sample. It does run, but if now I change the sample to be wrong, let's say here it's 004,024. So if it goes like this, it should be invalid. What happens now? Oh, condition failed. Look at that. It's a long condition, but it's fine. We could make it like 3 different things like asserts, but this is fine too. Does it make sense to use ensure like this? Import. I didn't know that macros could be imported like this, but I think it's, yeah, it's nice to read it like that. Yeah. So this condition failed, and do I have, like, if I pass Rust backtrace, does this, ooh, look at that. I do have a backtrace. Maybe not, yeah, and it points to the correct place. That's awesome. So yeah, anyhow, seems to be much better for error handling than the Rust like built-in errors, at least by default. I mean, it's not like Rust errors are or results are bad or anything, but they are like a little bit less friendly for development than just panics, I think. It makes your code more robust, but panics give you more information when they happen. So yeah, it's a pity that you lose something when using results. But this is quite nice, and I think I'll probably be changing or using anyhow on other daily solutions too. Let's actually change maybe the well, we have already done this, so yeah, we are done with what we came to do. That's great. We can also time. Are we still running on time? Yeah, 50 milliseconds. Yeah, it's not super fast, but it's not slow either. So we can also change our template to use anyhow result. And let's add a comment here to do use anyhow result instead. I don't know if it will probably change, because we had to change that okay or to context. So maybe changing this type alias to be anyhow results will be a bit annoying to do. Well, it's not something that I will do now, but I will leave it as a to do here. But okay, this is nice. I think I do prefer, and also I did want to try anyhow for a long time already, so this is a nice excuse to add it as a dependency. So let's say change assertions assert cause into error propagating ensure cause. Okay, and I think that will be it for this video. We did quite a bit of refactors, but they were all like incremental and nice. And now the solution, it's I think something that, well, at least the main method is much more readable than before. It's much we did manage to extract a lot of the complicated logic for following the breaks, and also generalize some things to have like part 1 and part 2 be pretty straightforward once you have counted all of the break faults. So yeah, this was a nice refactoring session, and I want to continue on solving puzzles, but I will leave that for tomorrow. That's it for today's video, and thanks for watching. See you later. Bye bye.